So this is an example of angle side side. So if we take a look at our what's been given, we've been given a fixed angle, 22 degrees, side and side. So this represents an angle side side situation. So we need to remember that there are now two triangles that we have to consider. Now the other triangle that we're going to consider then is the one that looks like this. It's going to go in this direction. So that length is going to be 5. Try to draw the same angle here. So it's going to form this isosceles triangle with the other length of 5. And we extend this line here. Okay, so this is the other case that we have to consider. So setting this up, I'm going to set this up as angle A, angle B up here, which can change. Okay, the angle B changes from the little angle to the big angle. I'm going to call this C1, and I'm going to call this one C1 and this one C2. So the angle here is C2, this angle here is C1. So because we have the angle and opposite side pairing with the 22 degrees and 5, I'm going to set up my ratio. So I'm going to have sine of 55. So sine 55 degrees over 5. So it's not sine 55, but sine 22 degrees. My mistake. Sine of 22 degrees over the opposite side length 5 is equivalent to, so we're going to pair up the side 11. So it's going to be 11 and sine of C. Okay, and then we're going to solve this for the values of angle C. So this is 22 degrees in here. So I'm going to rearrange this, and I'm going to end up with sine of angle C is equal to 11 times sine 22 degrees over 5. So I get sine of angle C is then equal to, we end up with, it looks like it's going to be 0.824. Okay, then we solve for the angle C, and I'm going to write this way. The arc sine of the ratio 0.824 is going to be equal to angle C. And I call that C1 because when I solve for it, you're going to see that that angle always ends up being acute. So angle C1, then, using the arc sine, I'm going to end up with 55.50 degrees. So that angle in here, I'm just going to maybe highlight that. So that C1 of 55.0, that's going to be this one here. Okay, so that's going to be that angle. So I'm going to write it in small, but this is 55.50 degrees. Now C2 is going to be the supplementary angle because we know that this angle is also 55.5. So then working out C2, I'm just going to do this here. So in parallel, C2 then is going to be the supplementary angle of that. So when we work that out, that works out to be 124.50. Okay, so that's going to be C2 here. I'm just going to write that in. I'm going to maybe highlight that in a different color. So C2 is going to be this angle in here, and we calculate that as 124.50 degrees. Okay, so that's going to give us two different triangles, which is also going to give us two different angles in B. So we're going to call this B1, and then that one is going to be B2. So this is going to, sorry, my mistake. This is B2, that's inside the smaller triangle, and then this angle here, the bigger angle will go with a bigger triangle, which is with C1. Okay, so then I can calculate angle B. based on this, adding 22 and 55 together and subtracting that from 180 degrees. So I end up with 102.50 degrees. That's for B1, and then angle B2 in the smaller triangle, and this one I can highlight a little bit better. So that by itself is B2, and that angle works out to be, when I add this up to 22 degrees plus 124.5, and then subtract that from 180, I end up with 33.50 degrees. And if we take a look at B2, that looks like it's about 33.50 degrees. So now I've established all three angles. I've got two sides of both triangles. I need the third side of that triangle. So I'm going to start with a smaller triangle, and I'm going to work out the length of this side length here, and that's going to be C2, okay, because that's going to go with the smaller triangle. So side C2, okay, and I'm going to write this as C. We're going to use the sine ratio, the sine law here. So C to the opposite angle is going to be side. So oops, sorry, I've got that wrong. I need to do B, sides B. Okay, so that opposite side is B, not C. Okay, so we're going to find this length B. This is B2 here. That's the side that we're going to solve for. We're going to use angle B2 to find that. Okay, so I'm going to write this as B2, side B2 over the sine of angle B2, which is 33.50 degrees. That's equivalent to a known side. We'll use 5 and sine of 22 degrees. Okay, so that's the paired side that we already had to start with. So when we calculate B2, this is over sine 22 degrees. When we do this calculation, the length of B2 works out to be 7.37. Okay, and then the longer side, so that's gonna highlight that. That's the length that we've got in yellow. And then the longer side is going to be this length here. This is going to be B1 all the way across from this angle here. So I'm going to do this in blue. So we end up with B1, the side length of B1, over the opposite angle to B1 is going to be angle B1, which is 102 degrees. So we're going to go sine of 102.50 degrees. Okay, so just making sure we know where these are coming from. There it is, there is going to be equal to 5 over sine 22 degrees. Okay, so that was our known side opposite angle pairing. Solving for B1, I end up with 5 times sine of 102.50 degrees divided by sine of 22 degrees when I rearrange that algebraically. And side length B2, when I calculate that out, it's 13.03. Okay, so we've solved for all three sides and angles of both triangles.